Hello everyone! Today I would like to review static routes. I want to talk about directly attached static routes, recursive static routes, and fully specified static routes. But before we continue, I would like to ask you to subscribe to my channel with notification bell on, and please show your support by hitting like button. So let's talk about it. Static routes are routes which are configured by network administrator on routers in the network. There are some advantages of using static routes. First, it provides precise control over routing. Whichever route you want, you can do it manually and achieve the result you require. There is also a second advantage. Using static routes requires zero network bandwidth. Comparing, for example, static routes to dynamic routing protocol like OSPF. OSPF requires some network bandwidth to exchange hello packets or LSAs between routers. There is no such network bandwidth consumption in static routes. But there are also some disadvantages. First disadvantage is administrative burden. If you have hundreds of routers in your network, it is very hard to implement your routes or implement changes in the network. And there is no network intelligence comparing to dynamic routing protocols. Where static routes can be used? First, they can be used where dynamic routing cannot be used because of limited router CPU and memory on a router. For example, OSPF requires some CPU cycles and some memory to calculate shortest path first algorithm. There is no such consumption of CPU and memory for static routes. And the second, routes learned from dynamic routing protocols need to be suppressed. In that case, you can also use static routes. And there are some static route types which we will discuss in this video. First, directly attached static routes. Second, recursive static routes, and the last one, fully specified static routes. We will review these static routes in the next few slides. Directly attached static routes. Directly attached static route is a static route which uses only the outbound next hop interface. Directly attached static routes can be used on point-to-point interface, and it is recommended to use them only on point-to-point interfaces. I will show why. Because they don't use ARP, and for them no need to worry about maintaining an adjacency table. The router assumes the destination is directly attached to the output interface and the packet destination is used at the next hop address. To configure directly attached static route, use the following command: IP route, network, subnet mask, and output interface ID. Let's review this example. Here we have serial link point-to-point connection between R1 and R2, and we have networks which can be reachable from R1, and there is configured directly attached static route on router R1. In this situation, when router R1 needs to access networks from router R3, it doesn't need address resolution protocol, and there is no ARP requests on this router while sending packets. Let's see this. For this example, we have this small network with two routers, R1, R2. They have serial link P2P between them, and there is already a static route configured on this router, show IP route, and for network 192.168.0.0, and it's directly connected. Show run. As you can see, IP route network mask, and outbound interface. Let's do simulation. Let's do just ping one of these IP addresses. So show ARP. As you can see, there is nothing in the ARP table. Ping 192.168.1.1. And as you can see, in this case, there is no ARP requests on this router. It just directly sent packet, ICMP packet, to destination IP 192.168.1.1, and there is no ARP request, only ICMP. Now let's review example with Ethernet connection between R1 and R2. The same, we want to send, for example, ICMP request. R1 believes that this network 192.168.1.1 is directly attached to the interface G01, for example, or G00 Ethernet interface, and it needs to find MAC address of the next hop IP. So it needs to send an ARP request. So let's see how it works. So here we have the same network, but now we have Ethernet cable connected between routers. We have IP address configured, and we have static route to 192.168.0.0 directly connected interface. So run IP route. You can see configuration for static directly connected route. So let's see what's going to happen if we do simulation. And we want to pin 192.168. Let's first show ARP. As you can see, there is MAC address for this host, for this IP, for this interface, sorry. And let's do ping 192.168.1.1. So I can see router wants to do ping, and it is doing ARP request. It is asking everybody for MAC address for this IP. And router R2, because it has this IP address, it replies and with MAC address 2901. And now let's see what we have here. It's still doing. Okay, show ARP. And now we can see we have in our ARP cache MAC address for this IP. But first, before we started pinging, router made ARP request for this IP address. There may be different and more dangerous situation. Not dangerous, but with issues. And I will show you next. So as you saw in example, in the case of Ethernet, when router needs to send request with directly attached static route, it needs to do ARP request. But there might be issues, and that's why it is recommended to use point-to-point interfaces. And I'm going to show you example where it may cause issues. Let's review quickly this example to see which issue we may have if we use directly attached static routes on Ethernet links. We have router R3 with loopback interfaces configured, and I'm going to ping these loopback interfaces from router R1. Router R1 has static routes, static route to these subnets with loop interfaces. As you can see, with it is directly attached static route with outbound interface gigabit 00. So let's show ARP. Let's check the ARP table. In ARP cache, we have only record for our interface on this router. Show IP interface brief at this time. Okay, let's try to ping 192.168.1.1. So router is trying to do ARP request for this IP address to get MAC address, because it needs to send a packet there. And so, and it got reply, and MAC address is this one. Let's try to ping 192.168.2.1 and 3.1, and everything is successful. And as you can see, in ARP cache we have MAC address for all our IP addresses, and this MAC address is the same. This MAC address is MAC address of G00 interface on router R2, because on routers by default proxy ARP is configured, and if a proxy ARP feature is configured, then router reply to ARP request with its own MAC address on the interface if it has a route to IP in the ARP request. Let's go to this router, and this router has static route configured to 192.168 subnet, so it replies with its own MAC address. So interface G00, as you can see, this is MAC address 009, same MAC address that we have in ARP cache. So if we disable, so IP interface G00, this is our proxy ARP cache enabled. If we disable proxy ARP cache, then let's see what's gonna happen. No IP proxy ARP. Show IP interface G00. Proxy ARP disabled. Let's try to ping again. Ping 192.168.1.1. Still show ARP, because we still have entries in ARP cache. Let's try to clean it. IP ARP. I'm not sure if it's command gonna work in this virtual environment. So ARP, it probably works, but let's see. So now our ARP cache is clean. Let's try now. 192.168.1.1. And our ping is unsuccessful, because when router R1 sends ARP request, it doesn't receive any reply. And in ARP cache you will see this record incomplete for a hardware address for this IP. For example, ping 192.168.2.1. So this is the problem. That's why it is recommended to use directly attached static routes for point-to-point connections. And as you can see again, the router did not get any reply for its ARP request, and now we have incomplete in our ARP cache. So these were issues which we might get if we use directly attached static route for Ethernet connections. It is recommended to use it only for point-to-point interfaces. And the last thing worth mentioning is that directly attached static routes require that the outbound interface be in up state to install route into the routing information base. Recursive static routes. Recursive static route is a route which specifies the IP address of the next hop address. For forwarding engine on the Cisco device, it is essential to know which interface an outbound packet should use. The recursive lookup occurs when the router queries the routing information base to locate the route towards the next hop IP address, and then cross-references the adjacency table. To configure recursive static route, use the following command: IP route, network mask, and then your next hop IP address. There is also additional keyword optional, which I didn't mention in the previous slide, which is distance or administrative distance. As you know, by default, static route has administrative distance 1. With this option in this command, you can make your route as floating route. For example, if you have also routes in your table for example, OSPF, and you make your IP route more than OSPF administrative distance, let's say 120, then if this route disappears, then your router will use this recursive static route or any static route. Let's review this example. For example, router R1 wants to send a packet to subnet on the router R3, and then we assume that it has a route to this network 192.168.0.0 and next hop IP address 10.12.0.2, which is this interface of router R2. When a router needs to send packet, it first needs to know which outbound interface to use. So it checks route table, and it finds that this IP address is directly connected on the interface G00. Then it makes a recursive query and makes ARP request to find out the MAC address of this IP, and then it gets this IP address from the ARP request and adds it to ARP cache. So now it can create layer 2 header to send packet, which next hop is this interface on this router. But this MAC address is just next hop MAC address of layer 2. It is not MAC address of this interface. Fully specified static routes. Static route recursion may allow the static route to stay installed while it changes route to a different outbound interface in the same direction in case a link fails. But there may be a problem if the recursive lookup resolves to a different interface pointing to the opposite direction. In such a case, it is good to use a fully specified static route which uses both the output interface and the next hop IP address. Using the outbound interface and the next hop IP address removes the recursive lookup and does not involve the ARP processing problem compared with using the only outbound interface. To configure fully specified static route, use the following command: IP route, network mask, and then you need to specify output interface ID and next hop IP. Let's see quick example for this part when it does not involve the ARP processing problem. So for this, we're gonna use the same network. I have loopback interfaces on this router, and I want to ping them from router R1. Section IP route. And as you can see, I have fully specified static route, network mask, outbound interface, and next hop IP address. So let's do packet capture, and let's do ping 192.168.1.1. Show ARP. As you can see, I don't have a record for 192.168.1.1 in the ARP cache, and let's see what I have in packets that were sent, and I don't see ARP request in the packets on the network. I can see only ICMP ping. So as you can see, it does not involve ARP. And now let's do example where I'm going to use all these mentioned static routes. So this is network which I'm going to use for this example. I have 4 routers. I'm going to configure loopbacks on router R1, R3, and R4. And I'm going to use directly attached static routes on R1, recursive static routes on R3, and fully specified routes on R4. In my virtual environment, I don't have serial interfaces, so I'm just going to use Ethernet and just configure these directly attached static routes as example. Just for example, success of this task is going to be when I be able to ping from router R1 this loopback, and for example from R3 these 2 loopbacks, and from R4 these 2 loopbacks. So that means that routes are configured correctly. So let's do this example. I already configured all IP addresses on all devices, so we can start from configuring static routes. I'm going to configure static route on R1, which is directly attached static routes, pointing to, I need routes to this subnet, and two loopbacks. But first let's try to ping 192.168.1.1. This is local loopback, and this is loopback on router R3. I'm not supposed to ping it because I don't have route to this one, but when I finish, this ping is gonna be successful. Show IP interface brief, show IP route, all good, conf t IP route 10.23.00.255.255.255.0 and outbound interface G00. Same for network 24 and same for route 192.168.3.0, which is subnet of loopback on router R3 and on router R4. Show IP route. So we have, let's do static. We have 4 directly attached static routes. Let's do router R3. On R3 I'm going to use recursive static routes, and I need a route to this network, and 2 loopbacks on R1 and R4. Show IP interface brief, show IP route, static, we don't have static routes, conf t, IP route 10.12.00.255.255.255.252. This is our network with subnet mask, with mask 30. And next hop IP for these routes is gonna be G01, IP of G01 interface on router R2, which is 10.23.02. Next one is network 24 with mask 24 and IP route 192.168.1.0.255.255.255.0.10.23.02 and on router R4. Show IP route and let's do static. So we have our recursive static routes pointing, which we need to reach our networks. And now let's do router R4. On R4 I'm going to configure fully specified static routes to this network, and 2 loopbacks. Show IP interface brief, show IP route, okay, conf t IP route 10.12.00.255.255.255.252. For fully specified static routes, I'm going to use outbound interface G00 and next hop IP address of G02 interface on router R2, which is 10.24.02. G00 10.24.02. Okay, and next one, route 10.23.00.255.255.255.0 G00 10.24.02, same outbound interface and next hop IP. Route 192.168.1.0 255.255.255.0 G00 10.24.02 and the last one, so IP route 192.168.30.255 255.255.0G00 10.24.02. Show IP route. Let's do static, and you can see our fully specified static routes. But even though I have static route to this subnet, I'm still not gonna be able to ping a loopback on router R1. Pin 192.168.1.1. As you can see, my ping unsuccessful. This is because of router R2, which doesn't know anything about subnets of loopback interfaces. It has only directly connected networks. So let's fix it. Let's configure 3 routes to loopbacks on router R4. R2 conf t IP route 192.168.1.0.255.255.255.0. I'm going to configure recursive static routes. And for this one, I'm going to use 10.12.0.1. Next one is loopback on R3. Subnet for loopback interface on R3, 10.23.0.3. And last one for R4, 10.24.0.4. Show IP route static. So we have these recursive routes to loopback subnets. Now let's try again. Ping 192.168.1.1, and it is successful. Let's do from R1. Ping 192.168.1.1. It is successful. Ping 192.168.3.1. Sorry, 1.1 is local, but still I ping loopback on R3, and let's do R4. And last test to make sure that everything is working fine, I want to ping from loopback to loopback. Ping, yes, target IP 192.168.3.1, repeat count 5, datagram size, timeout seconds, extended command yes, source address 192.168.1.1. So I'm going to ping this IP from this IP on this router R1, so I'm going to send with source address of loopback. Let's do, as you can see, sending 5 ICMP echoes 231, a packet sent with source 1.1, and let's do loopback on R4. 192.168.4.1. Yes. Source IP address 192.168.1.1, and we can skip these options. And as you can see, it is successful. So we successfully configured static routes, directly attached, recursive, and fully specified routes, and everything is fine. This is everything I wanted to show you. Thank you very much for your attention. I hope to see you soon. Thank you very much for watching my video. I hope you enjoyed it. Please don't forget to subscribe to my channel with the notification bell on and show your support by hitting like button. I hope to see you soon in my next videos. But for now, just goodbye and see you soon.